Hey everyone, I'm Nikhil, the founder and CEO at Future AGI. First of all, thanks a lot for taking time out for the session. And I hope you have a very informative session. Um, okay, so first of all, let's start with what Future AGI is and what we do. Future AGI is an end-to-end developer tooling platform for building reliable agentic application. We support enterprises with advanced evaluation, observability, and agent optimization techniques. We also have less than 100 millisecond guardrailing model to ensure that critical business applications are running smoothly without hallucination, and you don't have a lawsuit following you. Today, we have a very special guest with us and one of the best AI infra expert that I have known and met. He's a very dear friend, and it's a pleasure to introduce and welcome Sandeep. Uh, he's an engineering manager at Broadcom. Sandeep has 20 plus years of experience in software engineering and scaling AI infra for enterprises. He's an innovator and holds 10 plus patents for his outstanding work. Over to you, Sandeep. Would love to hear from you about your professional journey and about your knowledge, what you can share today.
Excellent. Thank you, Nikhil, for the kind
Yeah,
word. Thanks, Future AGI. I'm super excited for the session.
yeah,
Yeah, the knowledge that I have and the things that I'm seeing in the industry. Right? I work as engineering manager, as Nikhil said, focused on AI infrastructure and work the stack upwards for an end-to-end integration. Right? Uh, I have a few slides. I'll walk
yeah,
through what what it takes for a holistic picture of what it takes to build a scalable application end to end,
yeah,
right? And then we can dig deeper. It's a lot of information, right? Like I'll just share a glimpse of it. It's an idea for you to go deeper and explore. Let me get started. Again, quick introduction about myself. One specific thing I want to point out is like a keen interest in AI infrastructure and engineering leadership. Connect me on LinkedIn if anybody has any interesting topics to dig deeper and brainstorm. I'm happy to do that. That's my LinkedIn QR code. So today I'll talk a bit about introduction of like from 0 to 100, where we started and how we are progressing, right? A major milestone, a bit of a agentic landscape, how we are aligned with business, and then jump straight into what does it take to scale, right? In various aspects, various layers. How do we scale each and every layer? What are the things to consider when scaling? To start with, AI is started a long time ago. It has a huge history, even like very early 1900s. Right? But major milestone came in is in 2012. Right? This is when, like for an ImageNet competition, AlexNet model was created. It's the first time two GPUs are connected and used for the purpose of training a model. Right? Till that time, CPUs were used. It is expensive. They were using tens and thousands of CPUs to achieve whatever training that is required with just two GPUs, right? And this is also a major milestone in terms of starting deep learning from a convolutional neural network that was used
yeah,
for images, right? And that progressed significantly after that. And the next major milestone is in 2017. I want everyone to go and read if you are joining into AI, starting on AI. Attention is all you need paper by Google researchers. Uh, this is the architecture of transformer. Right? This is the basis for all the transformer architecture that majority of the language models are built now. Right? There is an encoder block, decoder block. Few models chose encoder, decoder, a combination of them and built, but like that is the basis, right?
yeah,
For this, and then trickle scaling laws and things exploded from them. And it's just a data point that I want to share where we are in the overall journey. If we take human level of performance as this bar, right? Almost so very early on we started with speech and handwriting recognition. There was a lot of research pre 2000 and progressed. Again, if we see the milestones of 2012 and 2017, things have drastically changed with transformer and the architectures, that almost all the significant capabilities that we expect, right, even including the PhD level of competitiveness, is all reaching human level, right? That so this is the turning point. Like almost everything in the last year or two, it is exploding. Right, and just a presentation of with the transformer architecture, I would say, is a starting point of generative AI, where with transformer we can generate things now, right? Not just classification and detection, but we can generate the next set of strings and next representation out, and that based on that, all the major milestones of agentic AI, physical AI, and quantum AI are leading into it. We are in very early stages of agentic AI. There are like some applications, right? Some published research and products out there, but it is very early, right? Like we are entering the world of a lot of automated, intelligent workflows that we'll see with agentic workflow. Okay. For the context of this meeting, we'll focus on agentic AI. Like this is a mental picture that I put together. Like when I think of agentic AI, this is all think of agentic AI. Work from down to up, right? Like the foundational aspect is the physical infrastructure of compute, networking, and storage. Right? We'll see a bit later in the talk as well. And the software layer of platform, integrating these all together, have the management layer, and also the parallel computing platforms with CUDA or OpenCL and everything integrated, and the services that can help orchestrate all of this pretty efficiently, to achieve and run the microservices that we need, and development integrations that we need to build, and observability platforms that can manifest into multiple clouds, right? It can be integrated and used in any of the clouds. The next layer I'll think of is foundation models. This is where the models are built, right? Like we need the physical infrastructure to build the models, right? This is where the model training, inference happen, and built on together, right?
Yeah.
And the top layer is the especially application layer that agents, be it like it started with prompts, it evolved into RAG, right? Next vector databases, graph databases, and kept on evolving into what we have as a state as agents, which could be horizontal, vertical, and enterprises have variety of use cases in building the application. Yeah.
Sandeep, maybe you have been working in enterprises throughout even from the foundation layers. So what do you think like is the biggest bottleneck right now in scaling these LLM applications?
Okay. Yeah. So scaling applications, right? Especially in the context of any like enterprise or consumer based application, what I would say is it's a pipe, right? It's
Yeah.
a pipeline, and it has to go through entire pipeline. Right?
Yeah.
Might start with agents and build some scalability aspects and achieve certain scaling at agents level, but like as we expand and build more and more, it has to be entire stack, right? It
Yeah.
start from here, but like you need to make sure what is the right model, like how is it performing, how do I own certain aspects of model, right? What amount of infrastructure do I need to achieve, right?
Yeah.
So and what is the level of configuration or tooling that we need to achieve that scaling. So that's one of the reason like I put a full stack here.
Yeah.
Irrespective of which layer you are working on, not all of us will be working on all the layers, but irrespective of the layer you're working on, you should have a decent understanding of entire stack, right?
Yeah.
identify the bottlenecks, right? Establish right observability platforms and integrate into the system, right? Establish feedback loops at various stages to get the feedback and build the entire stack, right?
Yeah.
So that is very important.
One of the interesting things that you have over here is public and private cloud as well. You have worked with a lot of enterprises for this. So is there any, switch that, where what is the decision making process look like? Okay, you know what? At what point we are fine with public cloud and what point, we want something in-house deployed with our own GPUs or with our own data center?
Yeah. Right now, if I see, I put three aspects here, right? Public, GPU, and private.
Yeah.
The way I see is like somebody who is into research, who wants to get in who wants to train a model quickly and get into the space. GPU clouds are very efficient at that. They are
Yeah.
very cost inexpensive. They are quick to spin off, very targeted, get targeted infrastructure for running the workloads, and public clouds for major players, right? Major established players like who wants to have, especially when I say public cloud, I include the hyperscalers here. So you have an application or a vendor that you go with, and you're building on that stack, right? So enterprise is especially when it's a large enterprise, and that's how I'm seeing in the customer base, a large established company who wants to own end to end, and a quick application developing or entering either GPU or public clouds, but large
Yeah.
enterprises who have very specific needs on privacy, security, and want to completely have control on the data. That is where they are going. Okay. So let me move on. So business alignment, I'll say like everything starts with business.
Most important, yeah.
Yeah, like without business, it is hard to justify anything, right? So everything starts with this. Right? If you are all aware with the business model canvas, that is something that I iterated on and made a simplified version of it, especially for the case of AI and software development. These are the 5 boxes that any small company, like 2-3% company to billion trillion dollar companies, can be put into into these boxes. Right? The centerpiece is the value that the business is bringing in. What is the customer value that the product is building, and the customer who is consuming it. How are they consuming channels, and right, how do they integrate into their product and everything, and the revenue aspects of it, right? How are they paying SaaS subscription, like are a one-time payment, right? What is the total cost of ownership for the revenue that they're building? And the development process is the engineering internal aspect of it, right? Well, how is product management ideating on the product, engineering working on it? How is the execution of things to achieve it, and what is the cost structure in executing the product? So if we lay these things out, we'll get a very clear picture of what the business is, what is it, what are its strengths, or how does it play in the bigger context of the industry. Over a period of time, like what I observe is there are a few cultural nuances in organizations as they grow. Some are very customer obsessed. They start with customer, right? Whatever customer needs, and they build it internally, right? Entire stack based on the customer necessities. Right? There are companies who are heavily engineering focused. They are very keen on certain aspect of a engineering differentiator that they have, and they build on it and build outwards, right? Then they think of what is the value, how customer can adapt, and what is the cost structure, and build on it. Yeah? And some are investor focused heavily, especially private equity companies who, like, these are generally established companies that have like a clear revenue model that they work through. They work backwards onto what is the the MVP requirements, like what is the value that they can incrementally deliver to customers. But these are like these three, 1, 2, 3, right, are the three-legged approach that is mandatory for a business to run through, and there will be cultural nuances that can elaborate. In the context of AI and evaluation, business itself does not change, right? Like the way we do business will change, but the business itself will not change. Yeah?
Yeah.
So I've divided into two things. What are the KPIs I put in each box, and the top layer of KPIs that we can uh, value on and look into, and and the bottom layer of how can AI help achieve those KPIs, right? What are the aspects to look into, or how can AI help achieve those KPIs? Right? How can we leverage AI in order to build on that? Right? So yeah, these are various KPIs you can look into. They're straightforward, right? In terms of this one. But again, like just to reiterate, start with business, and scaling should not be for scaling's sake, right? You just don't want to achieve a million or 100 million user base when you're working with a small customer base, right? So work on your business model, understand what can help to achieve 2 million users, right?
Yeah.
And then build on.
Yeah.
Yeah. Okay, and especially for the startups and everything, if anybody is starting a company and looking into it, is definitely good to start with customer, right? Customer and customer KPIs, especially be it like what is the customer satisfaction, right? What is a customer effort score? What is the retention of the customer, right? What is
Yeah.
the lifetime value that the customer brings in, and how can we help improve those
Yeah.
metrics?
You said a very important point, right? Because like business KPI is very important, and for an AI startup and anyone working on this is what to double down is also important. So do you have any so these are the, I think, well established things, business model canvas that as you said, we can follow and we should start from here. But what is that one metric, the few KPIs that you think like startup, and how do they end up with, right? Because it's really hard to get lost in all these things, right? So how do we like end up with one KPIs which is they can have that as a North Star metric or something like that?
Okay, yeah. I think like very good point, and I think to start with, right? Like especially startups is a focus, and again, I said like different companies start with different aspects, and they can change significantly.
Yeah.
For the startups, especially, I would say to focus on this top right corner.
Yeah.
It is customer satisfaction that matters, right?
Okay.
Like how do we retain the existing customer? How do we build on it, right? And establish the right observability and feedback loops in the system of that journey, right? Get a regular feedback on the customer, either directly or indirectly through the feedback loops that the company has established, right?
Makes sense.
Build on it. That is the most essential thing that I would think of uh, to start with, and then like we can build on others.
Yeah.
But we have to start. That is a starting point. What is the customer satisfaction? What is the net promoter score that we are getting? And what is the gap in achieving those scores?
Yeah.
Right? You have the feedback loops established, and like your data telemetry that you have established shows what is lagging, right? Is customer dropping any of the place? Is the customer adoption? We have built an amazing AI integration, but is customer using it, right? If so, what is the retention of
Yeah.
customer in those workflows, right?
Yeah.
So that data points and that establishing that and building a KPIs around it is a very good and an important step I would say.
Yeah.
Okay. So let's jump right in. So we have seen the business aspect, like we establish a business, and let's work through the engineering side of things. How do you build in order to achieve this? To start with scaling loss and build from scaling loss, because like if we see uh, if we see the stack, right, models is a significant new aspects of AI, and in order to scale a AI integration, model is where especially the starting point for scaling.
Mm.
And there are three aspects in scaling up AI models. There is data, there is a infrastructure aspect to it, and the model itself. Right? When I say model, it could be parameter size of model and how we quantize the model and everything. Uh, so I'll dig on data and infrastructure, but like out of all these three, what is more important? The fundamental important thing is data.
Yeah.
That's why it started with data, right? Data scientists, data lake, data warehouses establishing, right? Even before building this transformer architecture came in, and we started building real LLM models.
Yeah.
Data is a starting point, right? The quality of the data is important. How you build the data is very important. Right? Once that is established, then comes the algorithmic aspects and improvements to it. Right? The model size, the parameters, I think like we have achieved 1.6 trillion parameters, and after that we stopped talking about the parameters itself, right? Because it didn't matter as much, right? There is a law of diminishing returns after that.
Yeah.
Right? It peaks out quickly after that. Um, so then the post training aspects came in, and the reasoning models came in with the test time reasoning, right? So these aspects have helped to scale up and continue to scale. We are with efficient post training and test time reasoning. There is currently we are again going in a straight up curve of explosive growth, right?
Yes.
Yeah. Okay. Let me start with the data as we are discussing. This is a data pipeline that I took a reference from SolidM, which is a data storage provider. This is a very good data pipeline model which gives an end-to-end view of how the data flows, right? With training, model development, and inference, right, and to the end. Right? So the data could be from various sources. It could be uh, public data that is available, and we are ingesting the data from public internet, public sources of data, or it could be an internal organizational data that we are using for fine tuning.
Yeah.
Have a huge amount of data lake with a lot of data that can be ingested for training purposes. How do we store? Where do we store? Right, all of this is an important question that comes in when at each of these blocks. Um, what I increasingly see is the data storage is consolidating into, especially with AI, into one or two aspects. Uh, uh, Mostly it is SSDs with NVMe capabilities, and NVMe storage boxes. That is where uh, majority of the new companies or existing data storage providers are transitioning into providing NVMe capabilities, which has extremely fast read and write scale at petabit scale. Okay. um, Especially when we need the data for models, when we need a frequent movement of data,
Yeah.
right, for model training, or when we are looking the inference aspect too, right? Like when we are inferencing, we need a lot of storage, This is NVMe is the go-to. Right? Um, that is good. Like, so there are abstractions on it, there are APIs provided, there is a aspect of object storage that enterprises likes a lot. We take the S3s of the world. Enterprises like to keep their data in the form of object storages. So multiple of these vendors are also providing object compatible APIs, so which can be used for storage and retrieval when we are expanding onto various stages of the data pipeline.
Yep.
Yeah, this is a quick glimpse of like how you prepare the data. It is again organization specific, model specific, and what are the requirements that can help prep the data, and various model training algorithms that are used to achieve the model. And we place the data, place the model, maybe quantize that, and you're hosting the model for inference purposes. And it could be
Yeah.
cloud hosted or private cloud, or enterprise hosted, or locally hosted on a computer, right? Depending on the size of the model. So we have the inference and the application consuming the inference. Right? Application might be calling onto RAG or prompts and agentic workflows using an inferencing of the data. So that's an important aspect. And the inputs that are provided is a data too, right? How do you feed that data
Yeah.
that we receive in and feed back into, and just the data? That's a learning. There is sufficient amount of prompts with the increased number of context windows that the LLMs are providing. A lot of tokens coming in as a data, which is very much can be used for training and optimizing, especially
Yes.
that in inference. What are the queries types like, right? How do we optimize the KV cache accordingly, so that like the inference is faster when we get the next set of queries.
Yeah.
Yeah.
And this is really interesting diagram because you need to think it like like infinite loop over here. When you start it, it's all about data, prepare it, and then you have so much data coming in when your unit application is deployed. From that also you need to constantly learn like where, and that is also like a data source, as you said, right? Like what are the customers are asking, where maybe not performing, you're not performing, and then you have a feedback loop again. I think this is really exciting map. Sandeep, maybe, so I've heard like data is actually the biggest roadblock in making this really fast. So any insider information that that you can share, that how enterprises are making it really, the whole development really fast from this. It's really a manual task, having cleaning data, having a high quality data in place. So any techniques that you can share?
Yeah. So yeah. Purposefully, I'm not going too deep into the specific of the company. Again,
Yeah.
with a disclaimer, and these are all my personal opinions, right? Not
Yeah.
organization. So that's an important thing, right? It is a specific requirement that builds onto this, and on how we manage the data. Uh, First step is establishing the pipeline, right? What is the pipeline? Again, going back onto the KPIs and the ideas that we have with the feedback loops that we are establishing. Where are the bottlenecks for the data? Right? How do we get the right data in place, and how do we build on it, and how do we prep the data? Preparation, unfortunately, is a huge space. Data preparation, and
Yeah.
that is something that is heavily invested with a lot of tooling, lot of again, it depends on the cloud provider that you're using, right? Be it Amazon or Google, Azure. Based on each of the services have huge SQL, NoSQL data, like transactional, archival data. So there are various storage tiers, storage solutions, and data warehousing and data lake solutions that can be used. Like for simplification, I would stick back to the fundamentals that you want to build on. eh? What is the purpose of the data, right? If not everybody is building a model, right? They don't have to do certain things, right? They don't have to uh, they don't have to do the process that is required for gearing up for model training, right? uh,
Yeah.
um, so yeah, that is where that is where how the data center is built, right? What is the kind of cloud that we are consuming,
Yeah.
what the tooling that is available. But yes, have the data pipeline established, get sufficient feedback loops, and build on it. That helps.
And like, I think one of the audience questions was that, like, is there like the pipeline looks different for like say multimodal data, like it's the same, or the underlying, maybe the design choices, the machine that we're using, how we're storing it, the tooling, uh, will that change significantly? Or let's say, or there is a very huge, like that in like if you choose one technology, you have to change that for your multimodal data.
Yeah, multimodal data. When we get into multimodal data, that changes the equation. Again, the data pipeline itself does not change.
Okay.
This is
Yeah.
this end-to-end pipeline. This is a pipeline that is considering model development, right? So if there is no model development for an organization, they bypass this, right? Like
Yeah.
prepping the data, and that data will feed on to the queries that you're making, right? It's an internal corporate data that somebody is using, host that in vector RAG databases, like or knowledge graph databases, right? uh, uh, and and, uh, and that will feed on to the queries. So that pipeline will change when we are into model development or not
Yeah.
considering model development. But yeah, the pipeline itself slightly changes, but overall it remains the same. Multi-model itself should not be, right.
Got it.
Our like it is a choice of the services that we make for SQL versus no SQL databases that can
Yeah.
accommodate multi-model, and that is where object storages are highly preferred
Yes.
by customers as well. uh, it is easier to store variety of data sets into and load onto when customers need. So yeah, it depends on the choice of services that we have and the pipeline that we establish.
Got it.
Okay, so let's move on. Again, this is the infrastructure space. This is a space I work on. Don't want to go too deep and bore you guys. So I put a smaller pictures of this representing each one: compute, networking, and storage aspects. How the space is evolving, which choices to make, and how to build on. I'll put like I'll tell few important things. Then if we want, we can go deep later. Uh, uh, Generally, GPUs are the standard that most of the industry knows, right, for training. But there is a term called accelerator that
Yes.
very few companies manufacture accelerator chips. For the reference, we can use them as XPUs. They have what does GPU get? Right, like vast amount of tens and thousands of cores that can uh, uh, streamline and help accelerate the floating point operations faster, right?
Mm.
So that can be achieved for a specific model, trained for a specific model. For example, you might have heard the term TPU. Google has TPUs, right?
Yes.
Tensor processing units, that are similar in architecture to GPUs, right? But customized for model development, right? For Gemini models, right? For TensorFlow applications, TPUs are heavily optimized for that, right? For our underlying platform. Right? So in order to achieve, okay.
Yeah.
Okay. Okay, just a second. Let me back around. Okay. So yeah, that is from that. Okay. From the accelerator itself. Um, and there are, like, even from the inferencing perspective, there are inferencing computing that is happening, right? Inferencing. So if model development takes 20% of the time in the data pipeline, 80% of the time goes into inferencing, right?
Mm.
How do
Yeah.
we optimize inference? Like, how do we improve inference, right?
Yes.
Inferencing has both physical infrastructure aspects to it and software platform and aspects to it. There are many processors that are being developed for inferencing aspect as well. Okay. Yeah, it's like a traditional switch that we can see. We can build on. Okay. And when we come to networking, InfiniBand is something that is widely popular and used, that NVIDIA promotes on. It is an optimized, faster way of networking with intelligence built into switching, right? With the use of DPUs. How do we build a faster networking? Right? Um, um, InfiniBand and Ethernet is stepping up onto building a consortium, ultra Ethernet consortium, to achieve the scale of InfiniBand. As we scale out and try to integrate lots and lots of GPUs, we are getting into a scale, like currently, if you take a large models, right? They are being scaled with 30 to 40,000 GPUs,
Yeah.
right? They are trained at the scale, and the scale can grow tremendously. Right, the number of GPUs that might be required for training can grow significantly. Right, one data point that I can say here is, if we want to achieve, like we are achieving task specific human level intelligence, but if we want to achieve a general human intelligence, right? Like our brain is 100 trillion parameters, right? 100 to 700 trillion parameters based on whom we speak to, right? But we are in the model development, we are only at like 1.6 trillion parameters. Right? So if we want to achieve that level of scale, we need massive computing and networking to achieve. Okay.
Yeah.
And storage has to step up, achieve the capabilities that it needs, right? There are a lot of innovation happening in terms of AI for storage as well, right? With direct storage and direct RDMA with a faster, again, like NVMe as a standard. How can we directly connect to PCIe switch that can connect to the GPUs and achieve the scale that we want? So, and there is an announcement as well around accelerated storage, where the storage vendors are working on to improve indirect accelerator.
Yeah.
So these are, like, not all these details are important, but like these are the fundamental things that build up the infrastructure. Right,
Yeah.
having an understanding and choosing the right infrastructure is very important. Yeah, yeah. So that's a bit. Okay, can move on. So yeah, as I was telling, inference is a major aspect to the overall model consumption, right? So I took a reference of the latest announcement from NVIDIA, where Dynamo is a platform that is being built.
Yes.
Right? So earlier, like, these are the optimizations that customers used to do specifically, and I try to achieve faster scale of inference. But now, like, somehow these are all baked into the platform itself, right? Dynamo itself is achieving all of this, are baked into the platform. So either using an inference platform like Dynamo, or integrating some of the best practices is very important to achieve a scale, right, that we want. Right? Again, it's not a problem for starters. It is like if somebody is starting and relying on a cloud provider for inference, it's not a problem. But as the organizations grow and they get bigger, inference is a problem that needs
Yeah.
be concerned. Everybody needs to understand inference, how to optimize inference, and how to like even get into model development. How do we build models? How do we achieve training or fine tuning, right, for specific needs? Right? So these are the problems that will definitely come in some stage of an organization, right? Then like getting into understanding what is KV cache, right? How do we optimize KV cache? What are the best practices, right? And how does prefill and decode work, and what are the efficient ways of optimizing them in order to achieve the scale is an important problem. Right? A lot of optimization happened in these areas, and it is all scaling onto the platform.
Yeah, I think we would love to add on something over here. We also have few deployed models, and we know like it was a really painful thing, like to keep it like low cost, but at the same time having really fast inferences at the same, and so we really literally have to do a lot of optimizations at that time, right? So we were targeting around like less than 100 millisecond for a model, and we literally have to do so we took it from 2 seconds to 100 milliseconds by doing all these things, and now I think it's really accessible. That is one of the very good things. For example, I remember in 2020, around like all these things like caching, even like having quantizations approaches were really starting to kick in, right? And then how do you quantize, and then how do you do smart routing, and how do you distributed caching and distributed inferences. But yeah, I think with this, even like startups can, with because a lot of companies are coming with their competitive edge, their models are doing something different, and even like we have seen like models have been deployed on edge or in a specific customer environment, right? So how do they achieve cost effective inference at the same time? They are very scalable. It was like a research thing, but like now it's little democratized, and we don't have to literally spend months on this to happen.
Yeah, yeah. Yeah, very good point. I think like what Google has done by outsourcing Kubernetes to the world for internal orchestration of
Yes.
containers, NVIDIA has done by open sourcing uh, Dynamo, right? How to efficiently optimize inference. I think that is very essential with the GPU's usage. Things might change, as I told, like the where inference processors themselves they come in, but we have to see how it evolves. Right?
Yeah.
Is it inference processors, or is it the platform? How do they compete? How do they align, and what will be the best way customers consume?
Yeah. I think someone asked like, so what is the benchmarks looks like for this for Dynamo as compared to, let's say I'm doing some, traditional type, maybe tried on, inferences, or even just my own, for example, PyTorch based inferences. So how does like that benchmark looks like? So how much more gain do we think that we can expect, right? And one more thing, like, okay, what can be the very important, the best thing that I can optimize on this to get the most important gains? I know like everything is important, but like in this whole pipeline, if you see, Nikhil, I think you guys need to focus on this part first,
Yeah.
right? Yeah.
Yeah, yeah, the benchmarks are published, and they are available in the NVIDIA
Yeah.
site itself. There is anywhere with a comparative deployment of GPUs like H100s or Blackwells. There is anywhere between like 10 to 40x of improvement depending on the type of floating point operations that we use, right? Especially depends on floating points that are used, and depending upon the type of the data, type of queries, and everything. So yeah, I think yeah, it is evolving. The platform itself is evolving. It is just announced. At least like it is good to start with the because it's open source. It is of course it has its own licensing and everything. Uh, but yeah, it is good to start with these techniques of inference optimize and optimization, and if possible leverage the platform itself to
Exactly.
scale. So the question back to Nikhil for the case that you have, right, and the optimizations that you have done. So like you think adopting a platform like Dynamo is a good for the solution that you have, or you're reconsidering and uh, the techniques that you have?
Think it's a very good start. I would say, like, because in a startup we have very constrained environments. We are also experimenting around with it, and we also seeing the benchmark numbers. It really improves. You don't have to do all this into place and really spend months on doing that. That is not the mode that we want to develop as a startup. So yeah. It's a literally no-brainer for startups to actually start doing, so we are also exploring something called Dynamo plus VLLMs. How can we have quick, VLLMs plus Dynamo distributed inferencing. So that is also I think someone did online. So yeah, exploring all the things and like just starting from this was very helpful.
Okay, good. Let's get into the top layer AI agents. Again, if we specifically talk about like the layers and separate the layers, scaling up in the AI agents I like in, at least like in what I see and the members that I talk to, it's not a major problem to scale up the agents right now.
Yeah.
The challenge is more on building more reliable solutions, right? As we
Yes.
move from the world of deterministic to probabilistic world, where right the responses can be different, right? How do we ensure consistency, and how do we build a reliable system? Reliability is a number one priority. If that is achieved, especially in the world of agents, I'm saying, I think certain aspects of RAG have achieved a certain level of reliability, but agent, that space is evolving. But I think like end of the day, agent, the top layer of agent, and we don't get too deeper into the lower layers. It's an application, right? You are building an application, and model is your provider of the data and build on. So then go with the traditional best practices for scaling of an application, right? How do we iterate and build the best practices around iterative development? How do we again, like the one of the key aspects of the things that I was telling, right? How do we deliver incremental value, right? How do we
Yeah.
optimize for incremental delivery of value? Yeah. So that's an important thing to look at. Consistent value delivery. Uh, Set entire pipeline, development pipeline, in order to achieve that model, and the deployment can be best practices from microservices and even driven approaches of development. Use using of Kubernetes and scaling up and scaling out of the application using containers is the best way to deploy. from a design aspect, when like somebody is designing the agentic workflow, keep them, things are changing every day, and we
Yeah.
think like this is the way to go now, and build something. Tomorrow something is announced by major player, and
Yeah.
things change drastically, right? So again, like best principles of computer science design around composable architecture, keep it modular and flexible, so that like we have to plug and play, switch certain model for certain aspects, or an implementation that you have that model is doing, and you feel that like what model providing is superior, and want to use, like abstract higher level, and play a different game, I would say. So yeah, I think like yeah, design for flexibility, and go there, and adapt the best model evaluation practices, right? Is this the right model you need uh, for your consumption? What are the best practices? How can you leverage
Mm.
model, right? So, and as I repeatedly said in the presentation, establish feedback loops.
Yeah.
The entire engineering focus should be at any given point of time, either in development through by establishing the development pipeline, right, the deployment pipelines. So and the telemetry and the dashboards around it, right? How do we see and monitor and establish the right amount of expectations, and how do we fix them, right? So they all play a very important role in the
Yeah.
process. So yeah, build an engineering focused team, right? Get the best engineering mindset into the team, establish these processes, so that like we can quickly course correct, right? With an incremental delivery, like there are issues, right? Like there major providers have major outages, right? So what is constant is there will be issues and outages. Uh, plan plan for that, plan that, keeping in mind, right? Be fault tolerant, like designed to make sure how are we risk averse in the situations like that, and design for the for the for the worst case, and ensure it can
Makes sense.
recover reliably if that hits. Yeah, these are some of the things that I would say to consider for from the agentic agent space. Right? So yeah, that's all I wanted to cover. Like I think we have few minutes. We can go into any questions that anybody has. I can
Yeah.
share my
I
perspective.
think very super insightful conversation, Sandeep. Really enjoyed it. I think we can take the ground for. Okay.
There are some questions I
Yeah.
see the Q&A, right?
Yeah. So have you tried used OTL data to trace the agent outputs for evaluations? That is
uh,
one of the.
yeah, so that is there in the Q&A, right? Yeah.
Yeah, yeah, yeah. We just like we can take the Q&A now. There are a lots of questions. We can. I think I also have a few questions. Maybe we can take that now. So one of the questions was by Nick. Have you tried OTL data to trace the agent outputs for evaluations?
Okay. So from the agent output itself, right? I didn't try the specific hotel data. Again, like this is a perspective I bring in. I work from bottom up. Uh, Start with infrastructure and model execution, evaluation of model is a customer for infrastructure. So I
Yeah,
build upward from that. I didn't try this particular one, but interesting. I'll check it out.
yeah.
Okay.
And I think Parth was asking me, how does your team determine where to scale pre-training versus post-training versus test time reasoning?
Relation metrics are useful at each stage.
I think that it's the last one. It's basically where like how to determine where to scale pre-training versus post-training or test time reasoning.
Yeah. So yeah. So these evaluation metrics and different stages of scaling, right? these are for model development. You are building a model, and you're trained, like you're applying the techniques for pre-training and post-training, right? How do we improve the model performance at
Yeah.
training stage, right? Especially coming into the metric itself, it is for it is for accuracy, right? Like what is the accuracy and the scale that the model builds on, right? And how do we improve on the improve on that, right? Yeah, like optimize for accuracy, optimize for the size targets that you're looking for, the scale at which that you're looking for, and the response time that you are receiving. Yeah?
Mhm.
Those are the important metrics that one can look for when going into determining, do we need I think the intent of the question is like, sufficiently pre-trained and post-trained, do I need any further optimization, right? I think like
Yeah.
we can stick to the fundamental question about the metrics and see. Yeah, very, very. There is a lot of depth into the questions. So I want to be cautious about.
Okay.
Yeah.
Yeah. And the first question was like, any idea how do we align business evaluation strategies with with the core need? I think it's more about how do we connect more tech evaluation strategies with business evaluation strategies. For model evaluation strategies, we have some few evaluation criterias. Then we have business KPIs. So how can we connect both, or what's the strategy around that?
Okay. Yeah. 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 You, like as I was telling, like you're starting with the KPIs. You have a
Yeah.
business KPI that you want to work on. That KPI with the help of the pipeline, right? Data pipeline, deployment, engineering pipeline, and the feedback loops that we establish should give a where the bottleneck is.
Yeah.
Okay. Again, going back to the question that we were discussing, that bottleneck could be in any of the layer in the stack, right?
Yeah.
You have to consider the stack holistically, and then identify from the pipelines whether it is a data problem, is it like infra, like I'm training on a smaller or inferencing on it smaller infra, time to scale up the infra, right? How do and iterate, right? Quickly iterate and improve, and build towards the KPIs that we need to, right? It is starting with the KPIs, you're evaluating onto where the problem is with all the pipelines I've discussed,
Makes
establishing,
sense.
identifying how we can improve.
And I think one more question is around model evaluation. I think the last you talked about, you need to have good strategies around model evaluation. So what is your approaches to iteratively model evaluation? For example, when you created it, then you're going for deployment, and then you have that in production as well. So what are the frameworks or things that you're using so that you're making sure that all the deployments are incrementally good and better as they move forward, and then finding out, okay, where your AI is not performing well in production, and having that as a feedback loop, maybe very quicker feedback loops.
Yeah, yeah. Yeah, this again boils down to the metrics that we want to look at. Right, what are the metrics that are most important for us in terms of model? Like, is it so? Especially, right, accuracy is very important. Right, relevance of the responses that
Yeah,
we get in. Right, and like and constraints are very important. Regulatory compliance is very important. The biases that can impact it is business specific, right? So identify what is important and build on them, right? Build on those specific aspects of the data metrics. I don't want to go into the specific tooling itself, but yeah, observe for these metrics, understand you're getting the right amount of data, the right amount of parameters, and with accuracy relevance that you're receiving, and
yeah,
on it.
yeah. I think you have seen like majority of the people talk about, you need to have these feedbacks loop in place as you were talking about, because things can go really wrong in place. And like this is a very good architectural design that you proposed, Sandeep. I think really great to have this conversation with you. I also learned few points today. I think I hope the audience also have gained a lot of insightful points from this. Thanks a lot, Sandeep, for spending time and taking out and actually preparing the whole PPT. I know you do a lot of things. You have support startups as well. You have very busy job schedule as well. But thanks a lot for taking time out for this.
Thank you very much, Nikhil, Vrinda, and the entire team of Future AGI.
Yeah.
All the best, and glad I could share some perspectives.